Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on December 29, 2025, just 4 days ago. It tackles the so-called artificial hive mind effect, where models get repetitive, introducing a new prompting method called CREATIVEDC that boosts semantic novelty by over 50% compared to standard baselines. The paper is titled Divergent Convergent Thinking in Large Language Models for Creative Problem Generation. And as we'll see later, the results for generating diverse educational materials are really impressive. Figure 1 illustrates the full CREATIVEDC workflow using a concrete example. On the left, the system receives a context. The theme is superheroes, and the technical constraint is to use Python lists. The process moves to the top right panel for the divergent thinking phase, where the model freely brainstorms 10 wild ideas, like a cape tangled in a time loop. Below that, in the convergent thinking phase, it selects the best idea, cataloging villain socks, and refines it to ensure it works with the list constraint. Finally, the bottom right shows the generated problem description ready for use. Okay, Figure 1 showed the process, but Figure 2 reveals the actual impact on creativity metrics. The panels on the left track semantic diversity, while the ones on the right measure semantic novelty. In every case, look at the blue distribution curve for CREATIVEDC. It is consistently shifted to the right compared to the gray base model and the red chain of thought baseline. This shift represents a massive gain, including a 63% jump in semantic novelty when no persona is used, confirming that the method explores a much richer semantic space. So, while the previous figure visualized the shift, Table 1 provides the hard numbers that quantify these gains. First, looking at the top section without persona simulation, the results are striking. Notice the semantic novelty column. CREATIVEDC achieves a score of 0.30, far outpacing the 0.18 from chain of thought. Crucially, checking the utility column on the far right shows the score stays above 90%, proving the model does not sacrifice correctness for creativity. Finally, the bottom section confirms that even with persona constraints added, the method maintains its significant lead. Alright, while the previous table confirmed the quality of individual problems, Figure 3 demonstrates how the method scales. Here, we track the Venn score, which essentially counts the effective number of distinct problems generated as we increase the sample size k from 10 to 100. In the left panel without persona simulation, notice how the blue CREATIVEDC curve separates sharply from the baselines. By the time we reach 100 samples, it outperforms chain of thought by 72%. The right panel shows that even with personas added, this significant advantage in diversity remains stable. Well, having established the scaling advantage, Figure 4 now breaks down performance across different themes and programming concepts using 3 heat maps. In the first panel for utility, the top row for the cooking theme is bright blue, meaning familiar topics generate valid problems easily. However, in the middle and right panels, the science fiction and superheroes themes take the lead with higher diversity and novelty. This illustrates that creative themes unlock more freedom than everyday ones. Additionally, simpler concepts like variables on the far left consistently allow for more novelty than rigid structures like strings. So, having analyzed the results, Table 2 reveals the actual prompt structure that makes this possible. The instructions are split into 2 strict phases. First, the divergent thinking phase explicitly commands the model to ignore technical constraints and generate wildly different ideas based only on the theme. Then, the convergent thinking phase directs the model to select one idea and refine it. Crucially, it adds a retry loop, telling the model to go back if the chosen idea fails, which prevents the process from hitting a dead end. Wrapping up, the key takeaway is that explicitly separating idea generation from constraint satisfaction allows models to break free from repetitive patterns. This approach not only boosts novelty by over 50%, but also ensures high-quality, diverse educational materials can be generated at scale. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.